Hello, my people. Welcome back to the Soft Spoken Scientist. I'm glad you're here. In this video, we're going to build Lewis structures step by step, the way general chemistry exams actually expect you to. We're going to go over Lewis structures and formal charges. So let's get started. So, a Lewis structure is a way to account for valence electrons, which we'll get to in a second. Every electron must be counted, placed, and checked. If electrons are placed correctly, the structure is correct. So, Lewis structures show valence electrons, bonds, and lone pairs. Lone pairs are non-bonding electrons. Okay. So, and we'll go over these, and we'll use these rules and apply them when we do the practice problems. Lewis structure steps. Okay. Step 1, count the total valence electrons. Choose a central atom. Draw single bonds. Complete octets on outer atoms. Put remaining electrons on the center. If center lacks an octet, make multiple bonds. We are not checking formal charge yet. First, we must get a valid Lewis structure. So here's what you need to know. Group 1 on a periodic table is everything down. It's like lithium, sodium, right? And group 2 would be, beryllium, magnesium, calcium. Group 13 would be like aluminum, Ga. And then, group 14 would be carbon, silicone. Group 15 would be nitrogen, P, and then As. Okay, right? Et cetera, et cetera. That's how you know. That's a group on a periodic table. Okay, so this is the deal. This is what the charges would be on each of them. 3, 4, 5, 6, 7. Okay, so I think you guys got it. One thing that you need to know is that group numbers give valence electrons for main group elements. Let's work on number 1. We got H₂O, and it says draw the Lewis structure for H₂O, okay? So let's break down each element into what we have. We got H and an O. You know H is in group 1 on the periodic table, right? So there's 1, right? Times 2 hydrogens equals 2. And then O was in group 16, right? So look, 6. You can say times 1 if you want. There's only one O. You get 6. I'm going to add these two numbers to get the total number. What's 6 plus 2? 8. So we got 8 electrons. So I know that O would be the central atom because I have 2 H's. So I'm going to do it like that. You may be wondering, well, what does this mean? A line in this represents 2 electrons. Here's where they're located that they don't tell you. 1 right there, 1 right there, 1 right there, 1 right there. So there's 2 bonds, and there's 1, 2, 3, 4. So we have 8 electrons, and we need to use all of them, but we only used how many? We used 4. 1, 2, 3, 4. So we have to use 4 more. So look, I know that hydrogen never gets an octet. Oxygen does. Hydrogen only gets that 1 electron. And it did. Check this out. This hydrogen got this little one. This hydrogen got this one. So great, hydrogen's gone. And the last 4, I'm just going to put them on my central atom. 1, 2, 3, 4. And they're still in like little groups. Do not, and I repeat, do not do it like this, like 1, 2, 3, and then put 1 down there. That's really abnormal. They don't like that. So just do it like this. 1, 2, 3, 4. Okay? That's how you do that. Let's move on to the next one. But before you do, I want you to know the central atom rules. Never hydrogen, you just saw that. It's usually least electronegative. The central atom is usually carbon, nitrogen, or an S. Okay, practice problem. NH3. Draw the Lewis structure for NH3. What do y'all think the central atom would be? N, right? It's the only one. There's 3 H's. 1, 2, 3. Okay? But, so I kind of jumped ahead of the gun and wrote it out. But I have N, H. Okay, those are the only elements. I broke them down. N would be 5. H is worth 1, but there's 3 of them. Because N, if you look at your periodic table, N is in group 15. H is in group 1. So, you got 5, and then you got 3. What's 5 plus 3? Total of 8 electrons, right? So we have 1, 2, 3, 4, 5, 6. I used 6 of them so far. So how many was 8 minus 6? 2. I'm going to put 2 on top. 1, 2. And then there's a lone pair on nitrogen, and I have 1, 2, 3, 4, 5 around nitrogen, which is normal. It's better than putting on an H, and H only has 1, 1, and 1. That's the